Welcome to Geek Pro. In today's lecture, we will be discussing about engineering mathematics for GATE. And in engineering mathematics, we will be looking into calculus. So in calculus, it's important to understand what limits are. By limits, we are able to find out the behavior of a function. Let's say f of x of a function f of x. So we can find the behavior of this function near a point. Let's call it C, point C. So now this point, this holds good when the distance between x and C, that's point C, is very small. In other words, modulus of x minus C is small. So now there are two types of limits, the right hand limit and the left hand limit. So left hand limit is given as limit of f of x is equal to k, x tends to minus c. That is the left hand limit. If it's plus c, it's the right hand limit. So the left hand limit is given as tends to minus c. Now that we know what a left hand limit and a right hand limit is, let us discuss some of the situations where, let's say, situation 1 would be limit of x tends to minus c, f of x does not exist. Limit x tends to c plus f of x. The third situation would be both limit x tends to minus c, f of x, and limit x tends to plus c, f of x does not exist. Situation 3 states that both limit x tends to minus c, f of x, and limit x tends to plus c, f of x exists, but are unequal. So there are certain theorems on limits. This is very important. The first theorem states that if there is a limit like limit x tends to c f of x plus or minus g of x, this equation is equal to limit x tends to c f of x plus or minus limit g of x tends to c. Similarly, if it is multiplication, f of x into g of x limit can also be represented as LT. So here I'm going to represent it as LT. Limit of x tends to c f of x into limit x tends to c g of x. So even if it's multiplication, you can apply limits to both f of x and g of x. Again, similarly, if it's limit of f of x by g of x, x tends to c equal to limit of x, limit of x tends to c g of x. So discussing some of the important limits or examples of how a limit works, just to give you an idea. Say if it's limit x tends to 0 sine x divided by x, this would be equal to 1. Limit x tends to 0 cos x, limit x tends to 0 tan x by x. All these are also equal to 1. So how do we get limit of cos x is equal to 1? A simple way of understanding it is, if you substitute x as 0, cos 0 is equal to 1. But this cannot be done for every problem. To understand how to solve different problems, let us look into the L'Hospital's rule. Hospital rule. This rule states that if a function f and g, or for a function f and g, limit x tends to c f of x is equal to limit x tends to c g of x is equal to 0, or limit x tends to c g of x is equal to plus or minus infinity. And if limit x tends to c f dash of x divided by g dash of x exists, then limit x tends to c, f of x divided by g of x is equal to limit x tends to c, f dash of x divided by g dash of x. What f dash of x and g dash of x means is the differentiation of f of x and g of x. So if there is a problem, example, let's take the same example that we took earlier. That's limit of x tends to 0 sine of x divided by x. So this is 0 by 0. Like I said earlier, if you substitute x as 0, sine of 0 is 0, x 0. So 0 by 0 is undefined. In this case, what we can do is apply the L'Hospital rule, which states that this equation is also equal to limit of d by dx of sine x, that is cos x, and d by dx of x, that will give us 1. So applying cos of 0, we get the answer as 1.